Good morning, everyone. Today we'll be presenting our project on work shift scheduling optimization using Python. My group members are Mahesh, Magendran, me, Satish, and Yuvanan. Introduction and problem description. Significance of workforce scheduling. Workforce scheduling is crucial for operational efficiency in service and labor-intensive sectors. Secondly, consequences of staffing imbalances. Overstaffing will raise the labor cost, while understaffing will lead to poor service quality and employee fatigue. And primary scheduling objective. The goal is to meet staffing demands while minimizing costs and avoiding employee overwork. Lastly is Excel Solver benchmark study. A prior study used Excel Solver to optimize part-time employees' schedules with labor constraints. Project objective and scope. Model replication. Replicate the Excel Solver linear programming model in Python to ensure accuracy and consistency. Second is scheduling optimization. Optimize part-time employee scheduling to meet daily staffing demands with minimal staff. Thirdly, worksheet constraints. Ensure each employee works 5 consecutive days, followed by 2 days off as per labor rules. Fourth is minimizing workforce size. Determine the minimum number of employees required to fulfill weekly scheduling needs. And lastly is advantages of programmatic approach. Highlights scalability, flexibility, and automation benefits over manual Excel solver methods. Next, my friend Yumana should be presenting of the methodology.
So this is about linear programming module formulation. There is 5 of it, which is defining decision variables, objective function, staffing constraints, implementation with PULP, and solver integration. So defining decision variables is model shift starts days as variables representing employees beginning their 5-day work cycles. Objective function minimizes the total number of part-time employees required to satisfy weekly staffing demands. Staffing constraints ensure daily employee availability meets or exceeds required staffing levels for each day of the week. Implementation with PULP uses Python's PULP library to define variables, objective, and constraints in a linear programming framework. Solver integration automate solutions, finding by integration PULP with optimization solvers for efficient workforce scheduling. Detailed solution and Python implementation. Python code structure overview, shift modeling and constraints, optimal employee distribution output, and also verification with Excel solver. The workforce scheduling problem is modeled using PULP, defining integer decisions variables for shift start dates, formulating an objective to minimize total employees, and applying constraints to meet daily staffing demands. Each employee works 5 consecutive days, followed by 2 days off. Constraints ensure daily demand is met by summing employees working that day based on their shift start encoded in a binary availability matrix. The solution provides the number of employees starting shifts each day to cover demand optimally, minimizing total part-time staff while detailing the distribution across the week. The PULP solution matches the Excel solver results exactly, confirming 23 part-time employees are needed with identical daily shift start allocations and validating the model's accuracy.
Now I'm going to explain the Python code that we use. First, we put import pulp, which imports the pulp library to define and solve the linear programming problem. The second one, we create a linear programming problem called work shift scheduling with the objective to minimize the part-time employees. Then we define the days of the week, which represent 7 days of the week, 0, 1, 2, 3, 4, 5, 6, Monday to Sunday. And then we put the decision variables. Xi means number of part-time employees starting on day I, for example. For example, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday must be integer and non-negative. And then we minimize the total number of part-time employees across all 7 days. And then the demand equals to 17, 13, 15, 19, 14, 16, and 11, which is daily required number of employees from Monday to Sunday. The constraint, which is from the line 9 to 11. For each days, you need at least demand D workers. A worker for 5 consecutive days starting from the day they begin. The covered by means which is calculate which worker are working on the day. For example, if today is Wednesday, which is D equals to 2, the formula calculates which workers started in the past 4 days and are still working today. The model solved in line 13 means solve the linear programming problem. And for the output result, line 14 and 15, we tell to print the status and minimal number of employee needed. For the line 16 and 17, it shows how many employees are assigned to start on each day of the week. Thank you.
So the result analysis is minimal staffing requirement, shift start distribution, and validation of optimization models. The optimization results indicate that 23 part-time employees are required to meet daily staffing demands efficiently. Employee shift starts on different days, with 6 beginning on Monday, ensuring full coverage and adherence to consecutive work days policies. The Python PULP model replicates Excel solver results, confirming the solution's feasibility and reliability for workforce scheduling.
The objective of our project is to schedule part-time employees efficiently so the company can cover daily staffing needs, ensuring each employee works 5 consecutive days with 2 days off, and minimize the total number of part-time employees used. Okay, we solve this using a linear programming approach in Microsoft Excel with the solver tool. We start by listing each day of the week from Monday to Sunday across the top. Below that, we create cell to represent how many employees start their 5 days and shift on each of those days. These are this variable represents the number of workers that start on each day. They will determine total staffing for this week. These are called our decision variable. We don't know the value yet. Solver will calculate them later. Now we create a shift pattern matrix to show which days are worked by employees starting on a specific day. For example, if an employee start on Monday, they work from Monday to Friday. Okay, now for each day, we calculate the total number of employees available using the formula. For example, for Monday. Like this. This formula multiplies the number of employees starting on each day with the matrix value 1 if they work, 0 if not, and sum the total if give us the number of employee available that day. Okay, now we go to the data type and open solver. Then we configure the solver as a set objective, the cell with this one. Then to minimize the total amount, we choose minimize. Then by changing variable, we put this one. Okay. Then we must add constraint. So add. Now you can see the constraint out. Okay, why solver? Because the solver find the smallest number of employees starting each day that still meets all staffing requirement. Okay, now change to simplex LP, then click solve, and then solver give us the optimal number of employees to start work on each day. The module ensure all daily needs are covered. Employees get 2 days off and total recon is minimized. We can now create a very efficient weekly schedule. You can see the changes. In conclusion, the methods show how a real world scheduling problem can be solved efficiently using the linear programming in Excel, which help reduce cost and improve staff management without trial and error. Thank you.
Comparison: Python PULP versus Excel solver. There is 5 of each, which is user-friendly interface of Excel solver, limitation in handling complex models, scalability and control with Python's PULP, automation and testing advantages, and suitability for advanced scheduling problems. Excel solver offers a graphical user interface that is accessible to users without programming skill. Excel solver struggles with scalability and repetitive scenarios, testing in complex optimization tasks. Python's PULP provides a programmer environment allowing detailed definition of variables and constraints. PULP enables automation of large-scale models and supports multiple what-if scenario analysis efficiently. Python PULP excels in flexibility and reusability, making it ideal for evolving workforce scheduling challenges.
These are our reference. This is the coding reference. These are also our references. This is the conclusion. This accurate replication of Excel solver result, the Python PULP model precisely matched the Excel solver output, requiring 23 part-time employees to meet daily staffing demands. Scalability and customization advantages. Python code-based approach enables greater scalability and customization, facilitating handling of more complex scheduling scenarios. Validation for real-world application. This project confirms Python with PULP as a robust alternative to Excel solver suitable for practical workforce scheduling problems. Enhanced integration and automation. Python supports automated workflows, scenario testing, and integration with larger systems, surpassing limitations of Excel's GUI solver. And that's it from us. Thank you very much.
Thank you very much.
And that's it from us. Thank you very much.
Thank you very much.